From last time's class, we were talking about AC values, and we had mentioned tulikuwa tumeongea kuhusu peak value ama amplitude, tukaongea peak to peak values, mean value. Now we had also talked about RMS value and how to calculate them. Tulikuwa tumeandika two formulas. Now, for example, this question: calculate the RMS value of a sinusoidal current of maximum value 20 amperes. Remember, when we were talking about RMS value, we said that if you are finding the RMS value of a sinusoidal wave, the formula is given as, let's say that is our wave. The formula of finding this RMS value is 0.707 times the maximum. The RMS, in this case, we are talking about current. The RMS current is given by 0.707 times the maximum value of the maximum value of current. And the maximum current, the peak value, is that value of current ambayo is when measured from the mean point katika our wave, that will be our maximum value. But now we have already been given the maximum value as 20 amperes. So what will be the RMS value of that current? You will take 0.707 times 20. So you get that the RMS value is 14.14 amperes. Are you together? Tuko pamoja?
Yes, yeah. Amperes.
Yeah, because we are talking about current. So you've been told calculate the RMS value of the sinusoidal current. If it was in voltage, we have been told to calculate voltage, utatumia volts. Now, what I wanted you to see is this. The word here is sinusoidal. If it wasn't sinusoidal, then you won't use 0.707. Utabidi sasa utumie other. I don't know if you remember, kuna ile njia nilikuwa naambia you have to divide. Mfano, let's say your waveform inakaa namna hii. Shape yake ni funny. It is not being supplied at constant frequency, and so that means that our wave kuna mali ambapo the instantaneous values will be different kwa sababu the frequency of supplies ni tofauti. So that means you'll have to divide this shape into intervals, equal intervals. I don't know if you remember that method I had showed you, but we won't talk about that today. And nilikuwa nataka tu muone when you're given about when you have to read the question. Hii swali yetu ilikuwa imesema sinusoidal, so you'll just take the maximum value, you multiply by this constant 0.707. Now the second question, you've been asked to find the peak and mean values for a 240 main supply. Now, I told you last time that when you're told kwa mfano hapa 240 main supply, utapata that in most cases this supply from the source from the supply line, your 240 is the RMS value. So they won't write 240 RMS, no. It is assumed that that supply from the main is RMS value. Now we have the RMS value is 240 volts. So you've been told to find the peak, the maximum, and then you find the mean. And this is a sinusoidal supply. Shape yake ni so what is the peak value? Now remember that from the kama hii example ambayo tunafanya sasa hivi, the RMS value, whether it is current or voltage, will be given by 0.707 multiplied by the maximum value. Now in our example here, the voltage, the RMS voltage is 240. In our example, the RMS voltage is 240 volts. is equals to 0.707, the constant, multiplied.
Yes.
You can see.
I can see. It's okay.
Okay. Now, in our question, we've been given the RMS value. We already have this constant. That constant huwa ibadiliki. And we've been told to find the maximum ama the peak value. Now, I was saying that 240 is now equal to 0.707 times the maximum voltage. So what will be our maximum voltage? Take 240 divided by 0.707. What do you get? What will be a peak value?
339.4.
339.46 volts.
46.
Sawa. Now the mean value. How do you find the mean value? Remember that the mean value was being given by, kuna mtu anakumbuka? The mean value was equal to anyone. How do you find the mean value?
Mean value, I think
0.637 times the maximum value. So 0.367 times the maximum value. Now, our mean value will therefore be 0.637 times what is our maximum value? Ni ile value ambayo tumepata hapa sasa, 339.46. 339.46. So our mean value will be 0.637 times 339.46. You get that our mean value is 216.23 ama 24 volts. That will be our mean value. Any question?
Yes, mwalimu.
Uliza.
Hiyo mean hapo 0.637 imetoka wapi?
These constants, hizi hapa ni constants, hazibadiliki. This 0.707 time na hii 0.637 for a sinusoidal wave ambayo inakaa namna hii, those constant hazibadiliki. But for kama umepatia wave ambayo ina shape mbovu kama hii, itabidi sasa utumie njia nyingine kutafuta those values.
So hiyo ni swali la kwanza. Na kwa example tutapewa hizo constant values.
Constants unafaa kuwa unazijua, kwa sababu exam haitakuuliza utafute hii ambayo shape ni mbaya, so wana assume utakuwa utakumbuka hii, lakini kama zitakuwa ni sawa, inategemea sasa na ambaye ana set mtihani, anaweza weka akose kuweka.
Sawa.
Lakini wewe jua tu zijue.
Sawa.
Kuna swali lingine?
Yes.
Let's do the third example now. I want you to give me umepatiwa the mean value. Now you're being told to determine the maximum value and the RMS value. Umepatiwa mean value is equals to 150 volts. And you're being told to find the maximum value and the RMS value. Now, nipatie ni answers.
Soma nyuma kiasi penye tumetoka.
Swali ama swali?
Si swali hapa hivi kuna hiyo
Hapo chini.
ya lesson tulikuwa tunafanya hapo.
Maximum value itakuwa ngapi? What will be a maximum value? What will be a maximum value?
Mwalimu, 212.16.
Okay, that is one answer, 212.16. Mwingine? Si wote tumepata 212. 235.48 volts. Mwingine? Mwingine? Let us tufanye pamoja. Mean value is equals to 0.637 times the maximum value. Sawa. Mean value tumeambia ni 150 volts is equals to 0.637 times the maximum value. So what will be the maximum value? 150 over 0.637. Unapata ngapi? 235.48 volts. 150 divided by 0.637 ni 235.48. Now, RMS value answer yake ni ngapi? You now have the maximum value. The maximum value is 235.48. So what will be the RMS value?
166.48.
How did you get 166? Uh-huh.
07 times whereas we have got the maximum value
As 235. The answer ni 166.484 volts.
yes.
Is there a question? Kuna swali hapo? Uliza.
Peak value na maximum value ni kitu moja.
Ni the same thing. Unaweza itwa peak value, crest value, maximum value, amplitude. They all mean the same thing.
Hapo juu.
Wapi?
the second question yenye tulifanya naona kwa peak value ni voltage over 0.707, ndio?
Now
Na hapa mnasema peak value au maximum value mnaweka 150 over 0.707.
now let us look at this question. Tumeambiwa tutafute the peak value na umepatiwa RMS. Sawa. Now when you have RMS, RMS is 0.707 times the peak value, the maximum value. This is question 2, the second example. RMS tulikuwa tumeambiwa ni 240. Hii constant ni 0.707. Ndio maana tunasema peak value is 240 divided by 0.707, ndio tukapata the peak value as that. But now in this example 3, kile tumepatiwa mean value. And mean value is 0.637 times the maximum value. Nataka uangalie those two difference. Mean value is equals to 0.637 times the maximum the peak value. The RMS value is equals to 0.707 times the maximum value. So you can be able to find the maximum value using these two formulas. In question 2 tulikuwa tumepatiwa RMS, ni maana tukadivide na 0.707. Hii example 3 tumepatiwa mean value. Kwa hivyo utamultiply by 0. Utadivide na 0.637. Umeona tofauti?
Naona.
Okay. Kuna any other question? Now, I want to introduce the last thing for today. In easy sinusoidal waves, sine waves, if I was to represent them as an equation, the general equation of a sine wave is given by V. Small v is equal to capital V sine of omega t plus or minus phi. Now I want to explain what this means. This is the general sinusoidal equation. Now in this case ni ya voltage. Kama ungekuwa unaongea mambo ya current, ingekuwa small I is equals to capital I maximum sine omega t. This is not W, we need omega. Naito omega plus or minus this angle. Now, as we were talking about AC values, sijui kama mnakumbuka when I was mentioning when to use these small letters na capital letters ina represent nini. These small letters represent instantaneous values, AC values. So kama ni voltage, it is mfano the voltage at this point is different from the voltage at that point. And it is found, the current, the instantaneous voltage current is found by the maximum value at that point. The maximum value, this is maximum, multiplied by the sine of the angular speed. This is known as angular speed. Inaitwa omega. Angular speed times the time plus or minus this angle. This is known as the phase angle. Now, naomba huyo mtu ambaye ameweka hiyo ni mute. Now, when you look at this in terms of sijui ni nani najisikia pia Ocheng. Hebu mute kidogo. Okay. Now how we come up with this formula, nataka tuangalie, we represent that alternating current ama voltage as a vector. We represent it as a vector. What do I mean as a vector? A vector is a number ama a value that has both direction and magnitude. Iko na value na iko na direction. Now remember our alternating current is rotating. It is rotating. Now if this if I represent it as a vector, ni kumaanisha kwamba this OA, this value OA ina rotate anticlockwise at an angular speed omega. Tumezoea ile speed ya kawaida v. But now when I talk about angular speed, it is the speed of a rotating object about an axis.